Thank you very much, Mr. Chairman, and thank you, Mr. Chairman, for having this hearing today and organized as it is so that we can have a better understanding of the goals and the technology needed to achieve those goals. And I appreciate the witnesses, and I appreciate your leadership on this. We had a hearing on materials and the development of new materials and how that relates to human progress. We had that just yesterday or the day before. And when we're talking about the electric propulsion systems now, which is being presented to us as some new type of options that we have, how much of this is was dependent on new materials? Is this something that's part of this formula? Whoever wants to go right ahead.
It was quite dependent on materials, advanced materials, particularly when you deal with very hot plasmas. Mm-hmm. And you have to encase these plasmas in materials that will not erode away or melt away. So there are some special ceramics that have been developed that enable us to shine these electromagnetic waves that make the plasma hot, yet they go right through the walls of the rocket. So the material development has been critical. For us, some of the means of delivering this energy to the plasma requires materials in special antennas and special coatings that we use. Very new materials, of course, that are proprietary right now, but definitely materials is very important.
Did any of these materials? I have not been a friend of necessarily spending more money on fusion energy. I felt that was something that it doesn't seem like we've made much progress. However, I've been told that fusion energy, then our attempt to develop it has helped produce new materials. Is this part of that?
In our case, it is, and I think in the case of Anthony's as well. I think we both have the same pedigree from the fusion energy program way back in the. Well, he's a lot younger, but I go back to the 1970s when we were trying to develop fusion, and they told us it was 20 years away. So
well, I'm reminded of that expression where the young kid says, "I don't know where I'm going, but I'm on my way." And I think with fusion energy, as I say, I've been skeptical that we'll ever get to the point where we can use it for the production of electricity here, but we can see that there's benefits that we don't know are going to happen. And so I'm very pleased to hear that all that money that we spent on fusion energy didn't go to waste. So thank you very much. I'd like to ask Dr. Jurczyk about the choices here that we do have, and maybe it's like a choice between fission and fusion, I don't know. But the idea of having a refueling station, cryogenic propellant storage station there, is that with this type of new technology that we're talking about developing and putting into place, is it still important for us to do cryogenic storage facilities and basically refueling stations, if we have this capability?
Yeah, as Mr. Gerstenmaier mentioned, one of the real advantages of electric propulsion is the storability of the propellant. So for the 12.5 kilowatt thruster system, xenon is the propellant, and xenon is storable, and so we don't have to come up with capability to either passively or actively cool the system to keep that propellant available to the thruster system. However, if we look at more advanced chemical propulsion systems like LOX hydrogen propulsion systems for in space, then that would require advances in technology for both long-term storage of LOX and particularly hydrogen. Long-term storage of hydrogen is very challenging, and to keep the boil-off low, and you'll need active cooling to be able to do that, and then transfer technologies. So that would be more geared towards if we went to higher performing in space chemical propulsion stages. The real advantage of electropropulsion is the storability of the propellant and not needing to go to cryogenic propellants.
I'm not sure if that was a yes or no, but do we see that if we're going to be having a successful, there's talk that maybe we should, you know, you keep your eyes on the prize, like you say. I'm not necessarily involved with trying to eliminate all these other options we need to do in space in order to just get to Mars. But in order to do some of our moon, if we readjust so that it's moon first, then Mars, will we need a cryogenic storage facility as compared to a deep space propellant like was being described today?
Yeah, if we continue to go down the route of chemical propulsion, we talked about being able to produce a fuel with water resources on the moon, and then being able to handle that propellant, store it, and transfer it would be a capability we'd want to need if we wanted to use that ISRQ capability on the moon, as was mentioned previously. Yes. Okay.
Well, thank you, gentlemen, very much. It's been a very educational experience. God bless.